How many of you will likely have to take some kind of a student loan out in order to finish paying for college?
I'm so broke.
Okay? Yeah, it's a very real possibility for a lot of people. They will have to take a loan out to help finish paying the bulk of college, if not going to grad school. We're going to talk today about interest as it applies to loans like student loans, loans like house mortgages or car loans or anything like that. You want to be, in order to do the adulting of getting a loan, you want to make sure you understand what is in your best interest. So we're going to talk about 3.6a today. We're going to talk about the finance behind loans and interest. Okay, so interest and personal finance. Okay, so yeah, this could be very relevant to your adulting life in the very near future. When we talk,
There's no graphs.
so we only do have 2 lessons left, 3.6a and b, and that will complete the semester. And then we'll spend the rest of the weeks preparing for our chapter test and then our final exam. When you talk about interest, there's 3 kinds of interest. So what I'm going to do is I'm going to tell you the name of the interest, I'm going to tell you what it means, and then I'm going to give you the formula for it. All right, so we have three different kinds. We're going to start with simple interest. Simple interest is, dude, can I borrow $5? Sure, but you got to pay me back 6. Right? I mean, that's simple interest. You just fix an amount and you pay it back. The meaning of simple interest is that you make, it's paid at one payment. You pay your interest once at the conclusion of the transaction or the loan or the investment or whatever. So at the end, when you pay it back, you just pay your interest. You pay it once and it's done. This formula for simple interest is A equals P 1 plus R and T. A equals P parentheses 1 plus R and T. So what I would maybe advise you to do if you're taking notes on like a piece of paper that has a margin is over on the margin, you might want to start accumulating a list of variables. We're going to want actually P first. P and A and R and T so far were the variables we've seen. P stands for principal. Principal is what you start with at the beginning, whether you're either borrowing it or you're loaning it out to someone else. It's how much you start with. A is always the final amount. So in my example, if I borrow $5, that's my principal, but I have to pay back 6. That's the amount, the final amount I'm paying back. R is the interest rate. And T stands for time, and time is always measured in years. So even if you're talking about 18 months, you would make that 1.5 years. Okay. All right, so we have the first kind, which is simple. It's paid once, and that's the formula.
Sorry.
T is time. The second kind is called compound. You may have heard the word compound when you talk about like someone who breaks a leg or has a broken bone. It's called a compound fracture. When you talk about compound, it means it's more than once. So if you have a compound fracture, it's broken in more than one place. To have compound interest means you're paying interest more than once. All right, so the meaning of this is that you're doing multiple payments spread over time. This is the most common. Okay, if you have a credit card, you have to pay it monthly. Okay, that's paying multiple payments. If you're lucky, your credit cards, you could pay your whole credit card once and be done with it. But most people can't afford to do that. When you get a house, when you get your mortgage, you're going to have to pay a monthly mortgage payment, okay, monthly installments until you finally get it paid off. Okay, most mortgages are 30-year mortgages, so you make payments every month for 30 years until you pay it all back. Okay, that's called compound. The formula for that is the following. A equals P parentheses 1 plus. So it starts out looking exactly the same as simple. But then we have the fraction R over K. And then we have the power K and T together. So we have a new letter. All right, what's the new letter that we've introduced to this problem? K. All right, so let's add that to our list over here of what K stands for. K stands for your payments and how many payments you have to make, how often. All right, so you've got simple, you've got compound, you've got the meaning of those two things. Either you're making one payment and final and done, or you're making multiple payments spread over time. The final kind of interest is called continual interest. This is the worst kind if you're the person who is borrowing money. Okay, continuous or continual interest. What that means is that someone, especially if you have it set up as an automatic deposit, automatic out of your account, somebody's sucking money out of your account every second of every minute of every day. Okay? It's just a constant siphon away of your money. It trickle, rather than it just being like once a month. Okay? It's a continual, consistent, constant trickle out of your account. All right? So it is a constant, gradual accumulation over time. And like I said, if you get stuck with that kind of interest that you're paying, that is the word. Get yourself out of that loan. Okay. The formula for that is one that you're probably fairly familiar with. When I write it down, you might recognize it. Okay, it's the PERT formula. I usually put parentheses around my E and around my R and my T. So what we're going to do is your homework is just one word problem after the other. And so we're going to practice what these are like, but I want you to have your calculators out because the typing in of the values is where people will make mistakes, especially with parentheses. So I want to make sure you practice that. Okay, any questions so far? All right, let's take a look at our first example. All right, two sisters. Each invest $10,000. One chooses simple interest. Okay, one chooses simple interest of 4% for 10 years. The other chooses monthly compounding interest and it's lower. It's only 3.8%, but it's the same amount of time. So which sister chose better? Okay, which sister made the better choice? So one is choosing a higher percentage for a one-time payment. The other is choosing a lower percentage, but she's getting paid on a monthly basis. Okay, she's doing that on a monthly basis, which is the better choice. All right, so let's check it out. Let's try simple. So for simple, we use the formula A equals P 1 plus RT. Our P is what we started with. That's $10,000. 1 plus our R value is 4%. So what is that in decimal? 0.04 times the number of years. So that's times 10. All right, use your parentheses on your calculators to determine that. Okay, make sure you type it in with parentheses correctly. And let me know what you get. $14,000. Okay. All right, let's do the compound and let's compare that. The other sister is using the compound formula. So that's A equals P 1 plus R divided by K to the parentheses KT. So that'll A be 10,000. 1 plus, the R is it's 3.8, so that's 0.038 over what number? 12. Why do you think 12? So it said monthly. Okay, monthly is the amount of payments, and so that would be 12 for how many monthly months there are in a year. And then 12 times 10. So we still have to have the K. Now, this is where parentheses are excruciatingly important, that you need to have parentheses both around the base and around the upper number. Yeah, Quentin?
Wait, wouldn't the top equation be wrong?
All right, Douglas, did you get an amount? I heard you say an amount.
I got 14,614.
Point.
One.
That's it? Just 0.1?
Yeah.
We were talking about money here, so.
Oh, well, it was, okay, that's when it was rounded, but originally it's, 14,614.06. So that would be just 6.
Yeah, we do. It's money, so we want to go. Can you guys confirm that? Is anybody else getting the same answer? I need at least one other person to have gotten the same answer. Yeah, he's good? Okay. All right, so the second sister made the better choice. Okay, even though she was getting paid less interest, because she was getting more payments overall, she ended up accumulating more money.
So who is better?
Well, clearly one is bigger than the other.
Are we going through this?
This is an investment.
Oh, investment. Oh, yeah.
This is an investment, right? This is not a borrowing, right? If we were borrowing, yeah, if it was a borrowing $10,000, then sister number one would be better, right? But this is an investment. We want our money to be more. Okay, so yeah, it depends on if it's an investment or a borrow, right? Okay, that's a good point. All right, next example. Okay. Starting with $3,000. How long will it take of reaching your goal to double your money? Okay, how long will it take to double your money? At quarterly compoundings of 5.25%. All right, so that's our question. Starting with $3,000, how long will it take? So sometimes I find it helpful to make a list on the side of all my variables and assign the values to each of them. That just helps me to get started. If I were to do that, what would the p-value be? 3,000. What would the A value be? 6,000. Good job, because we are doubling our money. Now, the number 6,000 isn't in the equation anywhere in the problem. You have to infer that, right? You have to read between the lines and understand that we're doubling our money, so you've got to come up with that yourself. What about the R? It's 5.25%, but we don't want 5.25%. We want 0.0525. Okay, what about the time? I don't know the time. That's the question, so that's a question mark. And then what about K? Quarterly, what does that mean? Not 1/4. It means 4 times. Okay, quarterly, it's like when you got a report card every quarter, you got 4 report cards. First quarter, second quarter, third quarter, fourth quarter. There are 4 quarters. All right, so these are our values. So then we're going to use the compounding equation. So A equals P, 1 plus R over K in parentheses to the KT also in parentheses. So I've got 6,000 equals 3,000, 1 plus 0.0525 over 4 to the parentheses 4t. Okay, we're trying to figure out t. T's our question mark. Where is t right now? It's in an exponent. How do I get something out of the exponent? Logs. We're in the log chapter. All right, do I do a log first? No, got to divide first. All right, so what do we divide by? Okay, divide by that 3,000. That gives me 2. I still have parentheses, 1 plus 0.0525 over 4 to the parentheses 4t. All right, so I got rid of the 3,000. Now I can use a logarithm to help me pull the 4t to the other side, to the front. So make sure you put parentheses around your 2. And then pull your 4t, which is still in parentheses, in front of the logarithm, which also has parentheses. Okay, so now my t is out of the exponent, which is great. What do I do next? Okay, let's think about that. What do I do next to get that t by itself, Quentin? What about it? I don't need to. I could, but I don't need to. That's not going to help me get t alone. My goal is to get t alone. Sam?
Divide both sides by ln 1 plus 0.05.
Yep. Okay, I'm going to divide both sides by that whole mess. Make sure you use parentheses. It's okay to be patient. We don't need to work anything out. We're just going to write the division. So that gets rid of all of that. But that still leaves me with a 4t. And I've got all that still. All right, last step to get my variable by itself. Divide by 4. So all of this divided by 4. So when you type that into your calculator, make sure you use parentheses. Type in ln2 parentheses divided by the other ln with parentheses and then hit enter. Then take that and divide it by 4. Okay, you can't do this whole thing at once. You need to make sure that you do the top 2, divide it, hit enter. So this is what I want you to practice, and then divide it by 4. All right, t comes out to be 13.289, and that's years. Okay, keep going. All right, you want to triple your investment in 5 years. if you compound weekly, what should the rate be? So this is called shopping around for a rate. There's all kinds of websites and stuff out there, rate quotes and all this stuff. And you say, all right, I've got this much money and I want it to grow to be this much money. And this is my time frame. And then it'll tell you, you can figure out what rate you should be looking for. So then you go to the banks and you say, I want this rate. And the bank says, I'm not giving you that. And then you go to another bank and say, yeah, we can work with you. All right, you should know, as part of adulting, you need to know what your rates should be. All right, so let's try this. Again, I would advise that you maybe try a strategy like this for the problems. All right, we want to triple our investment. We've got 5 years to do it. We're compounding weekly. What do I put in for P?
I don't know.
We don't have anything, so I'm going to put a question mark. Okay, what do we put in for A?
Nothing.
3P. Because I want to triple whatever I started with. Okay, now don't just put 3, because then you'll have $3, and that will not get you very far. All right, you want to have 3 of whatever you started with, so 3P. So make sure you have that. All right, what do I put in for R?
Wait,
What do we put in for R?
you don't know.
Question mark. What do I put in for T?
5 years.
Okay, what do I put in for K?
52?
Very good, 52. Where did that number come from? Weekly. Got to know how many weeks are in a year. Okay, compounding weekly. All right, so we'll be using our same compounding equation. A equals P, 1 plus R over K to the parentheses KT. Okay, so A was 3P. P was question marks. We leave it P. 1 plus R was question mark. K was 52. And then my parentheses are 52 times 5. All right, I want to get R alone. What do I do to both sides? First, do what to P? We want to get R alone. I can't subtract P. There's no plus sign. I can divide P, though. Okay, let's divide P. What happens when you divide by P?
The P on the other side is gone.
All the P's are gone.
You're right.
So we have 3, and then 1 plus R over 52 to the 52 times 5, that's 260. All right, now, how do we get R by itself?
Ellen.
No, ln is when the R is in the exponent. Where is R right now?
Down there.
R's in the parentheses. It's not. How do I? Nope, not multiply by 52. What do I need to get rid of?
R. I
need to get rid of the 260. All right, I need to get rid of the exponent. Okay, we want to get rid of the exponent. We want to get rid of the 260. Now, an ln would move it to the front, but it doesn't get rid of it, and that doesn't really help me out very much. All right, so yes, we are going to use the 260th root. So what that's going to do is we're going to have the 260th root of 3. And on the other side, that's canceled out. And all we have is 1 plus R over 52. Okay, we got rid of the 260. What do we want to get rid of next? We're just trying to get R by itself. How do we get rid of 1? We subtract. So we'll have the 260th root of 3 minus 1 equals R over 52. Last thing to get rid of.
multiply 52.
Multiply by 52. Use parentheses, please. Put your 52 in front of your parentheses, and an R is by itself. All right, so let me show you how to type that into your calculator. So type 52 parentheses into your calculator. Okay, 52 parentheses. Then you want to find where in the world is the 260th root. Go to Math. And do you see the fifth option under your math list? Okay, choose the fifth option, which allows you to type in whatever root you want. So we'll put in the 260th root of 3, subtract 1, close your parentheses, and who's got it for me?
22.
Point 22,
0.
0.2202,
Oh.
right? 22. All right.
2.220,
Well, you got to think about where the thousandth is. We can even go 19 because we're going to be moving that decimal place, right? How do we move the decimal place? Bounce it, right? So this is 22.019%. So you still need 3 decimals left after your, so you have to have enough decimals so that when you move it, you've got enough left at the end. So now you just learned where the 260th root is on your calculator. Okay, 22%. You're gonna have a hard time finding a bank that'd be willing to give you that. They love to charge you 22%, but they don't like to give it to you when you're investing. But good luck. Maybe you can find one. Get lucky. All right, last example.
Lesson.
Okay. How long will it take an investment to quadruple compounding continuously at 3 1/8%. So again, it's helpful to me to go, think of it like a party, only a parquet, right? It's not a party, it's parquet. All right. What's my P?
we don't know.
We don't know. What's my A?
4p.
4p, that's what quadruple means. What's my R? 1/8. We know what 1/4 is, right? What's 1/8? All right, so this is 3.125%, but we don't want 3.125, we want 0.03125. What's my T? We don't know, so question mark. And what's my K? How many payments? Not 4, doesn't say quarterly anywhere. Continuous payments. Okay, so this is continuous, which means I switch formulas, and I'll be using PERT. So I'm using a different formula than I was using before because the monthly payments are continuous. So we've got 4p equals p e 0.03125 t. And we look at where t is, and we're trying to get t alone. So what would I do first to help me get t by itself? Divide by p, which gives me 4 by itself. It also gives me the e and the 0.03125t. Okay. Where's my t? Okay, what do I need when t is in the exponent? Now I need the log, right? So I'll have the ln, parentheses around the 4. I'll have parentheses 0.03125t down in front of ln e. Thankfully, we should remember that ln e is the number 1. So that helps simplify my problem down to 0.03125t because ln e was 1. Then all it takes is 1's division step, and I'll have ln 4 over the decimal 0.03125, which will tell me how much time it will take me. Got it, Sam?
44.36.
I just need independent confirmation that somebody else got the same answer. Yeah? Okay, good.